This video is for Chapter 10, Section 10.2 for the math activity Tessellations with Polygons. We'll arrange regular polygons and form regular and semi-regular tessellations. We'll use a set of 4 regular polygons, a triangle, a square, a hexagon, and an octagon with the side lengths the same length. This is a very specialized set. You can use virtual polygons for tessellation or find printable versions on our website. In question 1, an arrangement of non-overlapping figures that are placed together to entirely cover a region is called a tessellation. A portion of a tessellation with triangles and hexagons is shown here. It's a portion because you can keep adding triangles and hexagons and extend infinitely in all directions. Form and sketch a tessellation that uses at least 2 different polygons from your set. And remember, they have to entirely cover a region. There can be no gaps and no overlaps. And think of tiling a floor. In question 2, each polygon in our set is regular because all of the sides are congruent and all of the angles are congruent. If a tessellation can be formed with just one type of regular polygon, it's called a regular tessellation. Experiment with your polygons to find those that can be used to form a regular tessellation. And remember, the polygons have to entirely cover the region. There can't be any gaps and there can be no overlaps. You have a regular triangle, 3 sides, a regular square, 4 sides. You can consider what happens with a regular pentagon, which we don't have in our set. You have a regular hexagon with 6 sides. You can consider what happens with a regular heptagon, a 7-side polygon, and you have a regular octagon in your set. In question 3, this tessellation is semi-regular. It has more than one type of regular polygon, and around each vertex is the same arrangement. This one has a code 33344 because the triangle has 3 sides, the square has 4 sides, and each vertex has 3 triangles and 2 squares. I have a blown up view of that here, and we can say 33344, or you could say 44333, as long as you have your side numbers in order. It's a fine way to describe that code. The task for question 3 is to explain why the tessellation in activity 1 is not semi-regular. We know this is a tessellation, but does it match this semi-regular definition? In question 4, there are other semi-regular tessellations that can be formed using 2 different types of regular polygons. We have one here, squares and triangles. And so experiment with your polygons to find some of these semi-regular tessellations with 2 regular polygons, and sketch a portion of your tessellation and write the numbers for the code. And make sure that your tessellation can extend in any direction. In question 5, there are 2 semi-regular tessellations which use 3 different types of polygons. So find one of these and sketch a portion. Make sure it can extend in any direction. And then finally in question 6, we ask if there is any semi-regular tessellation which uses 4 different types of polygons from your set, and explain your thinking on this. That's it for Math Activity 10.2. It's really a lot of fun to play with the polygons and make shapes and think about beautiful tilings that you can make.